Mr. Bhasker Kakani Garu, co-founder and CEO of Bit Silica. Bhasker Garu is an alumni from IIIT Hyderabad, and he completed his postgraduate in VLSI and embedded systems from IIIT Hyderabad. And I welcome sir, and we are waiting for your insights.
Very glad for Professor Chandrasekhar and all the other faculty members of Osmania University and the members who have organized this event. I hope this will become a good platform for all of you to learn about what's going on across the world in semiconductor space, and specifically how India is positioned to in terms of growth in this industry. So, while we all hear about different electronic devices where integrated circuits are heart of these electronic devices like smartphones, laptops, desktops, servers and supercomputers, could you come up with what are the important components that are there in these integrated circuits that you could recollect from what you have seen in laptops, smartphones? What is the heart of the compute devices? Okay. So, what assists CPU in terms of computation? What are the other important modules in the systems that we see today? Memory, I/O devices. Yeah, control units are typically part of processor subsystems like CPU, GPU, accelerators. While we all know about the most important components of semiconductor devices, especially IC devices, one of the important backbone of the integrated circuits that we often give very less emphasis, especially when we are transitioning from academics to industry, which is interconnects. So, if you see a city, how city growth and development takes forward, having good connectivity for the cities, which will help with educational and healthcare and infrastructural capabilities to the cities, that comes through a network of roads, rails or any other transport mechanisms, right. Likewise, in a system, in an integrated circuit based system, while we have computing devices like CPU, GPU, or for that matter graphics streaming processor, and also devices like memory and storage, which will help store the data for the computation, there are other important aspects which needs higher attention, which will help us with respect to high speed compute in terms of data centers. Today's topic of interest is Compute Express Link. So, I will deep dive on why we landed in this topic and why it is of some relevance to students or academic faculty members, or for that matter researchers. When I landed in my first job working on a protocol called PCI Express, I was told your career is secured if you are able to focus on the project at your hand, which is a PCI Express based switch. So, looking back after 2 decades, I could see that it really is a matter of fact then, and I could till today say like technologies like PCI Express and next generation technologies which were built on top of PCI Express, which is called CXL, have 2 more decades for any of you who have picked up working on these technologies. You will have assured 2 more decades of career or prospects in terms of research or any product or solutions. This is the level of importance. So, when I was hearing 2 decades ago about the importance of an interconnect, I was not so much confident about what the scholars in the design space were talking about, but as I transitioned from company to company, from Tundra to Xilinx to Synopsys and eventually to my own company serving various customers, I realized how interconnects have become a center point of high speed compute, and how it has paved way for us to explore high end computational centric applications like LLMs and DNA missions all the high-end applications are highly centered about the interconnect technology improvements. The interconnect that we are talking today are which are backbones of the data centers, which connects memory devices, storage devices, computational devices, and caching. All the components are connected through the interconnect, which is Compute Express link, which is of our interest today. Yeah, this is a brief about the company that I have built along with my other co-founders for last 5 years. Probably you can know more about BitSilica if you get a chance to explore our website. So, as I mentioned, while we are all aware of the computational devices, memory devices, storage devices, the emphasis is missing with respect to the other important part of the high-speed compute platforms, which is interconnect. So, suppose you have high-speed computational devices. For them to compute, it needs data. Where does data sit? Either in memory or storage. So, immediate data lies in memory, and the device, the component that brings this data closer to compute is interconnect. Okay? If you have a high-speed device, a high-speed compute platform and high-speed memory, it is not good enough for us to experience high-speed data transfers unless we have a high-speed interconnects. So, these high-speed interconnects are typically serial in nature. So, there are many electronic concepts which will help us why these are serial in terms of data interference and the noise ratio. All these will ultimately has led us to a serial point-to-point interconnects like PCI Express and CXL, and these interconnects are backbone for high speed compute. I mean, like the strength of a lies in its weakest link. Suppose if I have a chain, if you try to pull both sides and see and experience the strength of that chain, it will be as strong as its weakest link. Okay. Likewise, here data transfers between memory devices and compute devices are basically as speed as your interconnect is. So, it is in this context having high speed, low latency, the highly expandable architecture based interconnects are of some importance today, and I will take you through CXL eventually. So, it all started with peripheral component interconnect, which is called PCI, probably ancestor of today's CXL. So, it has come up with connecting processing units and peripherals. What are the peripherals? IOs, the interconnect that connects between processor and IOs. This PCI was a parallel interface with a capacity of 133 megabytes per second. From there, we have gone on to have experience 64 giga transfers per second in terms of CXL. So, eventually from PCI bus we have transitioned to much more efficient PCI-X which have a bit more higher rates, but still it is a shared bus like PCI, and it was not able to meet the high speed requirements or high bandwidth or low latency computational power. So, eventually it has led to invention of PCI Express early 2020s, 2000s actually. So, 2006-8 is the time frame when I started my career in industry. That is when PCI Express was in Gen 2. So, the peripheral component interconnect express is the actual backbone of today's CXL, Compute Express link. So, the Compute Express link is a additional flavor, having additional flavors of PCI Express. So, if someone wanted to do research or have deeper understanding and insights about CXL, this is the starting point for you, PCI Express. Okay, remember this word and you can explore, try to understand what is PCI Express bit more deeply, but this is a first serial point-to-point high-speed communication protocol which is layered, having layered architecture like transaction layer, data link layer and physical layer, and the phi for CXL and PCI is same. So, further it has a bit more additional layers in CXL for different types of CXL devices. So typically, what are the kinds of devices that we see? We are all talking about interconnect, right? So technology doesn't lie in the wire, okay? Technology lies at the end of contours of those wires. Suppose you are having a computational device and you are having a memory device. Where does PCI Express or CXL sits? It is at the boundary interface of the interconnect and the particular device. That's where the protocol is getting implemented. We may call it as PCI Express, root complex, PCI Express, endpoint or switches, which will connect multiple IOs. From there, the today's growth path is towards CXL, which has capability in terms of memory expansion, memory sharing, memory pooling, and low latency, cache coherent based high performance interconnect. So these are the challenges. So today's topic, if you see, is high speed data transfers or compute express link. Where do we see high speed data transfers? We may see it in our high end devices, computational platforms, or servers, for that matter in the data centers. So the core aspect of today's use case is data centers. That's where all the applications that we use today in terms of ChatGPT, which is based on LLM, or DNA analytics, all the models, complex models are basically surrounding and implemented on data centers. Okay, what is data center? Can someone explain what is a data center? Having a deep understanding, at least a high level understanding of what is a data center is important for today's topic. That's where this technology is being extensively used, and probably use cases that I may discuss are centered about that data center. So you can, in a simplistic terms, data center is a congregated space of your high speed compute, high speed memory, or storage devices connected in a fashion where these are all shared accessible computational devices, where these are all pooled memory devices, where these are all extendable storage spaces. Okay. So a data center have the capability to deploy your the ChatGPT kind of LLM models, where you have computational devices, you have memory devices, and you have storage devices. So since I have been talking about memory and storage more often, and I may continue to use these two terms, I am trying to clarify. Does anyone know the difference between memory and storage? So, memory is something where the data that computers or computational devices wanted to process will store immediately. So the typical DRAM based devices are called memory. So today's DDR3, DDR4, DDR5, these are all called memories. So it is high speed, very costly, high performance storage spaces, whereas the storage devices are NAND flash based architectures. Today's SSDs, hard disks, these are all called storage devices. The processor will not directly perform computation on storage devices. It does computation on your RAM, okay, which is volatile. And when I refer memory, it is I am referring to RAM. When I am referring storage, I am referring to your external hard disk. Okay. So the high speed data centers which were built over the last decade have experienced a series of setbacks in terms of the nature of heterogeneous computational devices in data centers have given a limitation for optimally leveraging these connected devices. So, and then the latency is quite high because the devices are discretely connected to typically the processor and memory gap, which is of paramount importance to understand interconnect. So as computational power increased, your data memory computational memory speed also has to increase, while extensive research to improve the speed of processors or computational devices. Memory side, even though it has seen substantial growth over last 2 decades, but that gap is there. Computational devices are high speed compared to memory devices. Okay. So to reduce this gap, this gap has created a possibility for latency. When you wanted to do data computations across different devices connected in a data center, you will experience latency in real time applications like video streaming, or for that matter your traffic challan violations based models which are working real time models cannot afford to have higher latency. They have to be processed on the go. If you have latency issues, deploying those solutions with systems that experience high latency are unreliable. Okay? These are the typical challenges in the data center industry. The memory performance bottleneck, followed by the increasing heterogeneous nature of the computational devices, and the limitations of memory architectures in terms of their capability for expansion. So, these are typically being addressed in a technology called CXL. So, you have a concept called memory tiering, memory pooling, memory sharing, and memory expansion that comes in CXL, along with the high speed data transfer capability through cache coherency, as well as managing your storage through caching. These technology capabilities have given right platform for CXL to become mainstream player for data centers. Okay. So, there is as much I can discuss about CXL probably in next 15-20 minutes, but it is on you, whoever have some aspiration to deep dive into latest technologies, to research further on topics that we are discussing today. Okay. So, what is CXL? What is CXL? By now, by having discrete information of what I have been explaining over last 15-20 minutes, you must have got some idea about what is CXL. CXL is a computational express link. So, the very name highlights this is a link. Typically, interconnects are also referred to as links between different devices. Okay. Express indicates speed, computation indicates its ability to handle computational transactions. Okay. So, CXL is a high performance protocol designed to have a communication between CPUs, GPUs, or memories. Okay. So, what are the features that it brings in? As I mentioned, it is here to address the bottlenecks of data centers, which are high latency challenges and memory disaggregation challenges, or heterogeneous computational challenges. These are being quietly addressed by CXL. As I have given a hint during the history of PCI to CXL, I have highlighted like how CXL is a improvised or extended version of PCI Express. Okay. So, it has a physical layer as a common for PCIe or CXL controllers, while you have extra additional protocols, and PCI Gen 5 and Gen 6 are basically baselines for CXL 1.0, 2.0 and 3.0. Okay. So, Gen 5, Gen 6 are basically different versions of protocols. What is a protocol? It is a set of rules. Okay. So, if you do not have set of rules for any data transfers, it is very difficult to retrieve the information at the other end. It is the set of rules will help enable ensure data integrity of the information that is going across different networks. So, that is how protocols emerged, and the memory capacity, bandwidth and latency, these are the key improvements that CXL has brought us. And another important aspect, some of you must have worked on cache coherency problems during your campus preparation, during your project's execution. So, among cache, memory and storage, which is the fastest one? While I have emphasized DRAM technology is the core of memories like RAM, and NAND flash is the core technology underlying SSDs like your hard disk. Think through. So, why do we need cache? How it will help increase computational efficiency is something that most of you must be quite familiar. The most used data is kept closest to the processor, so that it reduces the requirement of processor to again fetch the data from memory or further from storage. It can readily use this data for computation and complete the operations in a rapid succession. Okay. So, PCI Express brings in cache coherency, memory pooling, and enhanced performance from PCI era, and it also builds switches and bridges. Okay. So, these are the important features. Probably while I am explaining use cases, you will understand what do they mean by memory pooling, or what do they mean by cache coherency. Briefly, I will take you through those case studies. So, as I mentioned, CXL is a technology improvement in computer architecture, especially for data center based interconnects, and there are so while PCI Express have devices like root complex, endpoint, and switches, the baseline for CXL, there are three types of protocols in CXL. CXL itself is not a single protocol, it has CXL IO, which is exactly PCI Express, PCIe. Okay. Then CXL MEM, these are memory transactions, so for host to be able to access memory from devices. And then you have cache, this is for host to manage cache across different devices and memories. These are the low level details about these three different protocols. While IO is focused in terms of data transfers, memory is focused for memory transfers, and cache is for cache operations. So, combinations of these protocols are resulted in terms of different devices. Basically, CXL have three types of devices. In the real time, whatever you learn in terms of a technology, it is getting implemented in terms of a devices. So, in CXL, in real time, if you understand, there are three types of devices. Okay, type 1, type 2, type 3. While we have protocols like IO, cache, and MEM. Okay, combinations of these protocols have brought in certain types of devices. What is a type 1 device? Typical accelerator or network interconnect chip. These comes under the category of type 1. What does it mean? So, it has your IO and cache protocol. Okay. So, for when I hear about accelerator, we all hear about the term called accelerator. What is the English translation of this accelerator? Which accelerates. Okay. In terms of computation, if we are using accelerator, that means it accelerates computation. What is your mainstream device who is responsible for computation? Your host system, that is CPU. Accelerator comes as an add-on for advancing or quickly processing the computation. So, these accelerators will need to have access to data which is proximity to the processing units. So, the memories which are proximity to host system and the memories which are connected to accelerator, these two memories, unless they are coherent, it is again a lot of requirement to transfer data from one point to another point. So, cache by way of cache coherency, instead of moving data from one node to other node, they maintain same data by way of cache coherency protocol. That way the data transfer need itself will be minimized. Okay. So, if the data transfer requirement is minimized, I am not saying reduced, I mean made 0, as soon as it is minimized, your latency challenges will have a solution. You will have low latency because you are not moving data, rather through a cache protocol you are trying to maintain same data across devices, and the data is accessible for both host devices and accelerators. Okay. So, the typical devices that are use cases for type 1 is accelerator and NIC. Okay. So, these are the topics. From here on to the end of the presentation, you will find very minimal in public domain. These are the use cases that comes, probably whatever is there before this is easily accessible across uh, different documents or so. So the type 2 devices are basically, it has IO, cache and memory. Okay, you have high dense computational requirements. Suppose you have a DNA problem, so DNA needs the formulation or computation of billions of data need to be analyzed for DNA analysis. So this may require high speed compute, high speed memory and storage. It requires cache, memory, storage, all of it along with the computation. For these kind of applications, type 2 devices are the best. Okay, whereas for simple acceleration or network interconnect chipsets, CXL, type 1 devices are good enough. So what are type 3 devices? So these are memory expanders. Suppose in a data center you have your memory proximity to your devices, which is later disaggregated as a memory pool. If you are not having enough memory in terms of the vast computational requirements of certain applications, then people will go for memory expander solutions, which are based out of CXL type 3 devices, IO plus MEM. So in a nutshell, if you remember, there are 3 types of devices in CXL: type 1, type 2, type 3. Type 1 is for accelerator or network interconnect, and then type 2 is for high dense computation, and type 3 for memory expanders. So even if you pick any of these topics for your thesis, you have many years to spend and research and explore. Probably these could be some of the research topics for faculty too. And then the most favorite term of RAM. Okay, so 1024 GB of RAM means 1 terabytes of memory. Okay, while we are imagining this data center have an access to 1 GB of memory, okay, sorry, 1 TB of memory, it is not the truth. Suppose you have a computational device 52, it requires more data, more storage and more computational power. It has more computational power. These are not homogeneous solutions, these are heterogeneous solutions. All 1024 nodes are not having equal computational power, while we are saying memory is same. So tying up these memories closest to the processing units will not give access for other computational devices to have access to the other memory. So by way of CXL based data centers, they are basically disaggregating compute and memory. So they are putting all the computes in one setup and all memory solutions in another setup, all storage solutions in another setup. So by way of this, suppose 55th computational device requires access to 10 GB of data, it will be having that allocation. Suppose device 1 to 40, these devices are only using 256 MB of RAMs. Okay, so they need less access to store memory than the devices which have a requirement of more requirement. So by disaggregating memory from computational devices, we are basically opening up a lot of memory pool. Okay, so this is the solution for this problem. So you have memory pool, and with this approach you will have efficient utilization of memory and more access for each computational device. So then, so now we have solved a memory problem in a data center. Okay, so you will have same size of memory in total, but access has been improved because we have pooled the memory and all the devices have access to all the memory units. Okay, so that's how we have solved the problem of memory expansion and pooling in data centers. So other problem is for accelerators. I think we have briefly discussed about accelerator problem. What is the accelerator problem? So you typically in a device, engineering students especially who wanted to pursue careers or for that matter education in electronics further, especially in semiconductor space, you need to be familiar with these words: host, accelerator. You Google it, try to see the images when you type host, host device, how it is different from host, how host is different from device. Okay. So here the accelerator is a add-on device. It could be your GPU or FPGA, which enables additional computation capacity in addition to your CPU. Okay. While we have discussed every device has certain on-chip memory, so accelerator having some on-chip memory and CPU having some on-chip memory will create a situation for accelerator. Accelerator is in a way trying to help speed up the computation for CPU. So the activities that needs to be done by CPU probably could be done more efficiently by accelerator. So these could be more efficiently managed through having access to both the memories, and having a cache coherency between the memories will help reduce the need for data transfers between memories. Okay. So if you maintain the highly used data common across both the devices with a coherent protocol, your latency challenge is solved. So latency can be minimized by way of CXL in terms of CXL cache. So the type 1 device that we have discussed, which is having I1 cache, will solve typically accelerator problem. So memory problem is solved by memory expander, that means type 3 device. This is type 1 device. Okay. Then comes another problem in terms of that comes under type 3. What is the problem statement? Storage performance often lags behind processing speed, creating bottlenecks in IO bound applications. When IO bound applications like your YouTube streaming is an IO bound application, we are hardly processing anything. Streaming video from here to centralized stations is IO bound transactions. So in such cases, you have very little tolerance for latency. Okay. So in such cases, it involves storage, memory and cache. So these are quietly managed well through these type 3 devices, and here comes the memory solution, memory expansion, cache, memory sharing and pooling. And this brings us to the final most the problem statement, which is for AML training efficiency. The language LLMs that we are discussing about being used for ChatGPT, that requires extensive processing of data. Data may be residing in your storage devices, which eventually brought to memory devices for immediate computation. So it involves involvement of computational devices, memory and storage. So here comes your type 2 devices in play. So accelerator with memory, or the high dense computational framework. So here type 2 devices, IO, mem, cache solutions will give a solution for this problem statement. And the high density servers, probably this is a mix and match of the case studies that we have seen. So the DNA problems, LLM problems, all high computational need problems are being solved through these devices. And this brought us to the end of this discussion. So probably very rarely people from industry talk about use cases which are more realistic. So that's why I have brought you use cases like memory expansion, the data center applications and AI accelerator applications. So ultimately the interconnect of the need of the interconnect for today's data centers is to have high bandwidth and ability to handle the heterogeneous compute and ability to handle the high latency problem and come up with a low latency solution, which has brought us here. So it is effectively a new age compute enabling connect efficient and innovative future. Thank you.
Sir, you said that for data centers, AI workloads and all, shared memory is better, but there are latency and bandwidth issues as well. So latency, you told some how to tackle it, but how will you tackle bandwidth issues, sir? Because GPU, whatever internal memory is there, it has very high bandwidth compared to the shared memory bandwidth. So that problem we have not addressed in this.
Okay, yeah. So since it has not come in the boundary of interconnects, I have not discussed about it at length, but have you heard of DDR? So DDR is a kind of memory so which is built on DRAM logic. Okay. So today we are talking less about DDR and we are talking more about high bandwidth memory. Okay. So high bandwidth memory is a solution for the bandwidth issues. So what is a high bandwidth memory? It is a simple stack of your DDR devices organized in such a manner it will result in high bandwidth memory. So high bandwidth memory solutions have been mainstream for AI and acceleration problem statements.
I'm Asif from Srinidhi. When we are talking about CXL protocols and CXL devices, how does CXL supports data protection and data security?
So CXL as a protocol has evolved from 1.0 to 2.0 to 3.0. 3.0 have the data protection and security aspects. So since it is a deep dive of the protocol, I haven't gone till that point, but CXL 3.0 have all the security and data protection protocols.
And the CXL, which is better?
Okay. So if you have followed the discussion, you could have got answer to this question. While AXI, APB, AHB are on-chip interconnects, basically they move data on the chip between your compute device and peripheral devices. Okay, that is within the chip. These are the on-chip buses. We will typically call them as on-chip bus, a parallel one which will move the data, whereas the interconnect CXL that we are talking about, these are high speed chip to chip for that matter between accelerators, CPU, GPU and your memory solutions. This will move data. So in a way there is no comparison between on chip and chip to chip communication because this is entirely different. But CXL fares well in terms of on chip or chip to chip.
For sharing your knowledge with our participants. Thank you very much. May I now request Dr. Shyam Sundar sir to felicitate our guest.